Good morning, everyone. This is John with Gun.Deals. Today, we are going to be taking a look at a new old ammo type that is competing in the same genre as the NGSW program, specifically the Sig Sauer 68x51 that is used in the XM7 and XM250. But there's also a competitor that just finished the crane testing, and that is from Shell Shock Technologies, the NAS3 case technology. But before we get into all of that, go ahead and like, share, and subscribe, as that is free and does help us out quite a bit. And if you think that they should have selected this over the 68x51 or not given every contract to SIG, go ahead and comment that in the comments down below. Now, getting into this article from Tactical Gear Tech, this is on a couple different sites, but this is just the article I selected for this video. Shell Shock's next gen 7.62x51 ammo tested. This is by Rivernox. Shell Shock Technologies LLC, a leading innovator in the ammunition industry, is proud to announce a critical achievement in its mission to redefine military-grade ammunition performance. The company's 7.62x51 NAS3 cartridge cases have successfully completed rigorous testing at the Naval Surface Warfare Center, Crane Division, one of the most demanding environments in the defense sector. The results: 0 case failures. Now, there is a couple errors in the article that is probably just a typo. So, for instance, they say that the tested ammo used a 155 grain bullet loaded at 50,000 psi and had velocities of 3,000 feet per second. If you look at some of the testing done by other people with 308 cases to get to that velocity or near 300 Win Mag, or 308 plus, basically, you need about 70 to 75,000 psi. So that 50,000 psi number is incorrect. Now, remember, the NGSW program already has a chamber pressure of 80,000 psi and a real world chamber pressure of about 77,000 psi with the military ammunition. They say it was tested under extreme pressure and velocity in belt-fed machine guns, including the 240 Bravo and minigun platforms. SST's 7.60x51 cases passed with flying colors, even under the violent conditions of automatic fire and harsh ejection cycles. Testing was conducted at ambient temperature, minus 40 degrees Fahrenheit and 160 degrees Fahrenheit, with all pressure and velocity benchmarks met or exceeded. Now, again, remember that the velocity was 3,000 FPS for the NGSW program, which the 6.8x51 utilizes a 113 grain projectile at roughly 77,000 psi to meet or exceed that standard out of a 13-inch barrel. This milestone underscores the durability, consistency, and tactical advantages of our NAS3 case technologies, said Peter Foss, managing director and CEO of Shell Shock Technologies. 0 case failures in such unforgiving conditions is not just a win for us, it's a validation for every warfighter and defense partner looking for lighter, faster, and more accurate ammunition. The 7.62x51 success joins a growing list of calibers, including 300 Blackout, 5.56, 6.5 Creedmoor, and the promising early results from 338 Lapua that are reshaping battlefield expectations. The company is now ahead of schedule with initial test samples for the 338 Norma, and tooling is officially underway for 50 BMG. The 7.60x51 will be available in summer 2025. Now, a little bit of background on ShellTech and the NAS3 case technology is that this has actually been around for a little while. So it's a bimetal case, kind of like the 68x51, although there are some other cases which we'll get into that just use a fully steel case, which kind of brings us back to Cold War Russian manufacturing technology, but I digress. Essentially what it is it uses a stainless steel base and a nickel alloy, stainless steel core for the rest of the case to ensure good extraction. Now, what that steel base does, of course, is allow you to load them to much higher pressures. So, for instance, 55 to 62,000 psi is what you'll get normally out of like a 5.56. However, with this, you could theoretically push it to north of 70,000 psi, which gives you a lot more velocity. Now, as I see it, there are two huge advantages to using this case technology in cartridges that already exist. The first one being that the cartridges already exist, so you already have barrels, bolts, and guns chambered in these that you do not need to develop whatsoever. So you can take this increased performance in the exact same package that you're already using, same magazines, same belts, same everything basically, and just increase the performance. Now, of course, there are downsides to that, which we'll talk about a little bit later. The second main advantage is that brass is heavier than steel and it's also much more conductive. So the cases themselves, at least depending on the specific cartridge that we're referencing, are up to 50% lighter. So whereas 6.8 by 51 versus 5.56, you lose a bunch of capacity and you gain a bunch of weight. If you simply take the exact same, say, 308 M240 or 7.62 by 51, of course, and you use this case technology, you get more velocity and less weight. And when you're carrying hundreds or thousands of rounds of ammunition, that is weight savings, and that is hugely helpful to people actually carrying the stuff. Now, of course, nothing is free. There are going to be some obvious downsides. Number one is you are going to have increased wear on your barrels and your bolts. Basically, anything that interacts on the inside, you have more chamber pressure, you have more powder to deal with, and that's got to go somewhere. All of that energy has to go somewhere. So, your barrel life is going to go down. Though keep in mind, for the NGSW program, barrel life was only at 5,000 rounds. So for a 308, if you go from 20,000 round barrel life to a 10,000 round barrel life, even though that might be kind of extreme, you're still well within parameters for the NGSW program. But it's not just going to be harder on barrels, it's going to be harder on everything in the chain. And so there will probably be new technologies, new barrel extensions, new bolts that are designed specifically around handling this hotter pressure. And to be clear, there are already companies doing special things with their bolts and barrel extensions. For instance, Knight's Armament has their E3 bolt and their specific barrel extension. Victor has their combat match bolt, which actually uses more material in their bolts. And then you have something like the Geisley with the REBCG, where they don't use standard material. They use what they call Carpenter 158 Plus, which is supposedly has like 100,000 round life, at least with standard pressure ammunition. So there are definitely ways to mitigate the extra wear and reduced barrel life, and you might think that this is going to increase costs, and of course the ammunition is more expensive. It just is, because the manufacturing scale is just not there, at least yet. But keep in mind that we're comparing it against the current NGSW program, where the rifles are somewhere between $3,000 and $4,000. The barrel life is also not particularly good, and the ammunition starts at $2 a round. And I believe personally that this technology is going to continue to spread, because you can use cartridges, barrels, bolts that are already designed and on the market, platforms that are already in common use, and simply change the case technology to get extra pressure, extra velocity out of the ammunition. So, for instance, Federal came out with their 7mm backcountry, which is rated for 3,000 FPS out of a 20-inch barrel and a 170 grain projectile. Keep in mind that we're not dealing with that powerful of a round with the NGSW program. For instance, we're only accelerating a 113 grain projectile to 3,000 FPS, so we don't need that much pressure. That's in the 7mm backcountry. But the 7mm backcountry, that cartridge is not particularly important. What is important is the promulgation of the case technology, which is their peak alloy case technology, which when you boil it down is just a proprietary steel alloy, which is probably pretty generic when you actually boil down to what it exactly is. The steel case is just stronger. It can handle higher pressures. If it's coated properly, its extraction should be very reliable, and it is of course lighter than standard brass ammunition, which isn't that big of a deal when we're talking about a hunting situation. But if we're talking about a soldier carrying hundreds or again thousands of rounds of ammunition, that can be a huge boost to soldier performance and non-related service injuries later on down the road. Moving back to the NAS3 case, it's out in the wild currently through several different manufacturers. You can get it directly from Shell Shock Technologies, or some other manufacturers are already utilizing their case with their own loads. For instance, Badlands Munitions is one of those guys that use a 85 grain projectile at about 2,700 FPS out of a 18-inch barrel, which is very heavy for caliber for 223 or 5.56, and that's also very fast for that projectile out of only an 18-inch barrel. AAC, American Ammunition Company, is another brand that is using the NAS3 technology to get some extra performance out of their 77 grain OTMs. And now, to be clear, this isn't just about heavy for caliber bullets. You also get that increased performance out of lighter bullets as well. For instance, where a standard M193 load might only be hitting 2,700-ish FPS out of a 10.5-inch barrel, which is a very short compact weapon. However, with the NAS3 case, you could be pushing nearly 3,000 FPS out of only a 10.5 barrel, which previously would only be achieved out of a 14.5-inch or longer. So now we can get even smaller, lighter, compact weapons that maintain the performance of their longer counterparts, with the obvious downsides of price, parts wear, and recoil. And one of the last examples I pulled up just for fun is a 300 Blackout 95 grain 30 caliber projectile cooking at 2,700 FPS, which again just goes to show that we don't need to develop a entirely new case technology bullet weapon system platform. We can basically use what we already have, just with some updated case technology and probably some slight updates to the barrel extension and bolt geometry to handle the higher pressure that these steel core, steel hybrid cases can give us. All of that while not relying on a single company to manufacture every single component along the way. And I would not be surprised at all to see this case technology used to grant some additional life to systems that are already in place. But with all that out of the way, gentlemen, let me know what you think of NAS3 or steel case technology in the comments down below. And with all that out of the way, thank you so much for watching. I hope you enjoyed. I will see you in the next one. Peace off.